We're going to be looking at proportional reasoning, and the method we're going to use is by using some diagrams. Our overall expectation is to solve problems involving proportional reasoning, and the specific expectation is to make comparison using unit rates, and we're going to try to use some concrete materials. This is a very difficult question, so we're going to read through it once and highlight what we think is important after. So 2 stores are advertising specials on oranges, stores A and store B. Oranges are sold individually, which leads us to unit rate. How much less would 30 oranges cost at store B than store A? Okay, what's important? The 2 stores are advertising specials. Okay, we got that. Store A, highlighted in yellow. Store B, we can highlight in green. These are their prices for their oranges. Oranges are sold individually, which is important. And how much less would 30 oranges cost at store B than store A? Okay, so when we have all this important information, we want to be setting up a unit rate, which would be very helpful for this. And in order to set up a unit rate, I'm going to first focus on store A. Okay, we'll do that in red. And we're going to have to make sure the rates are the same. Store B will do in green. So here's our store B. Let's write our info down here. Oranges and price. Okay. They're at 12 oranges at $5.52. And for store A, same idea, oranges and price. There were 8 oranges at $4.24. So first we're going to reduce this to a unit rate, and we're going to use a rate of per orange since oranges are an independent variable. So in other words, it's going to be dollars per orange. Okay, and this line meaning per means we need to reduce the oranges to the value of 1. So we want oranges to be 1 in both these cases. To reduce oranges to 1 in the store A, we need to divide by 8, so we'll divide our cost by 8 also. We'll take a calculator to find this. $4.24 divided by 8 gives us, oops, there we go, 53 cents. So it costs 53 cents an orange at store A. And doing something very similar, to reduce 12 to 1, we're going to divide by 12, and we'll divide our cost also by 12 to get our rate at store B, which is different than store A's rate. The cost was $5.52 for 12 oranges, 46 cents. So a better rate at store B. We can already see that. Now we want to use some concrete materials, so some ratios in this case. And in this one, it's going to be difficult. What I want to do is I want to keep in mind what we're trying to get at. Remember, we're looking for 30 oranges. Okay. If I set up a ratio like this, 1 to 0.53 and 1 to 0.46, it's not lovely to work with, right? And not only that, I need to take this and I need to duplicate it 30 times in both of these. So though we're set up as unit rates per orange, what I'm going to do is I'm going to change our value to maybe to figure out at 10 oranges what it would cost. That way, if we set up a ratio with the value of 10 here, okay, and again, it'll probably be a decimal number, that way we only have to duplicate with concrete materials that ratio 3 times to get 30. Okay, so I'll show you what I kind of mean by this. I want to move up to 10. Well, from 1 to 10, we know we multiply by 10. And it's actually pretty easy to multiply by 10 a decimal because we just got to move the decimal over 1 spot. So this would be $5.30, which makes sense. 10 oranges cost more than 8. With that same idea, let's move this down. Let's find out at store B. We want to move up to 10 oranges. And again, we just move the decimal over 1 spot, so it's $4.60, which makes sense. 10 oranges is less than 12. So here we go. So now I can build probably a nicer looking type ratio with concrete materials. We'll say stars represent oranges. Okay, so every star equals, and not just 1 orange, but 10 oranges. Okay, this way it's a little easier to work with. Now we're going to have to use 2 other concrete materials in this case. We could also use happy faces for store B since it's cheaper. We do know that. So 1 happy face will represent $4.60. Not a great value for adding up and down for our ratios, but that's fine. And let's find another material here. Star, flake, what is this? Flower. Every flower will represent our $5.30. Okay, that's store A. Great. So with that being said, I'm going to duplicate a bunch of these. Okay. Under store A, let's set this up. So store A. 10 oranges, okay, equals $5.30. Okay, and I could have represented this with 5 flowers. Maybe I should have. Change this to infinite clone and that to infinite clone. And actually, that's what we're going to do in this case. Let me set this up nicely. All right, so this is set up a little nicer now. Each of the large happy faces represents $1, and this small one's going to represent our 60 cents. So $1, 2, 3, $4.60. And each of our flowers will represent $1, the large ones, and the small one is only going to represent 30 cents. So we have 1, 2, 3, 4, 5, and this guy represents 30 cents. Okay. So at store A, okay, we know this is the flowers are the price. Each of these stars represents 10 oranges. Well, every 10 oranges, we need $5.30. Okay, so we can do this a few times over. Let's roll up. That's 10 oranges. This would be 20, which would again need another 5.30. And finally, this would be 30 oranges, which again would need another 5.30. Okay, so we kept that in mind. Store B here. Okay. Store B is the same type of idea. We need another 3 sets of stars. So let's copy and paste our 3 sets of stars here. Okay. And for each set of star, we need our $4.30 of happy faces. So we'll take them as one set, 2, and we'll bring them down. I can't quite see, so I'm going to scroll down and bring them in line. Here we go. 2, 3. Okay. So we've set these up. And what we need to discover here, okay, so we've visually set this up a little better. Remember, each of the large circles represents $1 value. And we know that store A is going to cost more than store B. So what I'm going to do is we've set up all of our ratios. And if you quickly were to count this all out, store A ends up being, there's 15 large values, so $15 worth, and there's 1, 2, 3 30-cent values, so it's $15.90. And if you count all the happy faces, you actually have 13 of them, I believe. Oh, I have sorry, actually it's 12 of them. Okay, there's $12 values, but there's 1, 2, 3 60-cent values. And when you add 60 cents 3 times, I said 13 because there's going to be an extra dollar on top. That's going to be another $1.80. So actually, it'll be $13.80. Okay, with that being in mind, we could just quickly subtract these two. Another way we could do this is reducing all our dollar values, right? We know that there are, we counted 12 of these guys, right? So if we got rid of all of them, all of our sets here, boom, 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 all 12. We can also reduce these by 12, right? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So there leaves us with 1, 2, we have 3 extra dollars. So there's 3 extra dollars there on top. But also, remember, we're reducing these happy faces, which are a little harder. Okay, because each of these little flowers is only 30 cents, 2 of these flowers together equals 60 cents. Well, that would be one of these happy faces. Okay, so when I get rid of one of these happy faces, it destroys 2 of these flowers. Think of it that way. Okay, I do another happy face. Okay, he needs to destroy another 2 of those smaller flowers, which becomes difficult because there's only 1 left, which means we got to reduce this by another 30 cents. And then we still have to take away this last guy, which is another, remember these equal 60 cents, each of these things. Okay, another 60 cents. So we're reducing our original 3 by 30 and then 60, which is 90 cents, which equals a value of $2.10. So there is a $2.10 difference. And if you just subtracted these 2 values, you would have found the exact same thing. a difficult way to solve this type of question. If you'd like to look at other ways to solve this question, just check out our other playlists on proportional reasoning.